So here we have the notes page for obtaining information from a graph. A lot of this is going to build on the previous skills that we talked about in the other video about finding the intervals when a function is greater than 0 or less than 0. And so with that, it involved drawing the horizontal line at 0 to see a visual of like when that function is going to be above or below it. So if we look at this first one, we want to know when the function f of x is greater than -3. So what that is asking you is for what x values will the function have y values greater than 3 or -3. So our answer will always be this interval of x values. And we're going to use interval notation for this as our solution. So if we look at the first one, we want to figure out where this is going to hit -3 on the y-axis. So I'm going to draw a horizontal line at -3. And we just want to find out where that intersects this with the function. All right, it hits a little bit before we get to -5. And then again over here, somewhere between 1 and 2. And then a little after 6, it looks like. So if we just estimate these, because we don't have exact points, we could see this might be something like -4.9, -3. That point right there. And then another one over here, this might be at, it's a little bit over halfway, so maybe 1.6, -3. And then this coordinate looks like it's just past +6, so I might say 6.1, -3. And so these x values are what we're going to need to be able to write our interval. If we look at the first one, we want to know when it's greater than, so it's going to be above that value. So all of this section here, that's between -4.9 and +1.6. So we're going to write that in interval notation with parentheses, -4.9 to 1.6. And they're both going to get parentheses because at that value, it's equal to -3. And our inequality is strictly greater than. But we do have another section, so we're going to use the union symbol to talk about this section out here that's going up forever and ever. So this section is going to always be greater than -3 from 6.1 to infinity. Because as far as I go out on the x-axis, it's still going to be greater than -3. It doesn't come back down. So if we change that inequality to the second one, it's now got the equal to for this. So that's the only difference. These sections were when it was greater than, so the only thing different is I now get a bracket because it can equal that value here. So at -4.9, it's equal to -3. At 1.6, it's equal to -3. We union join up the other section, 6.1, to infinity. Now, infinities will always have that parenthesis. They never get a bracket. The third one says less than this time. So now we're looking below the line here. This happens in this interval, which is from -infinity up until that -4.9. So -infinity up to -4.9. We decide, do we need a parenthesis or a bracket? We have strictly less than, so we use a parenthesis. But we have another section that's also below -3. So that would be from 1.6 to 6.1. All right, and the last one, the only thing different is that equal to, so it's going to turn that parenthesis at -4.9 into a bracket. And then brackets for 1.6 and 6.1. In part 2, or question 2, we're looking at the zeros of the function. So that vocabulary word zeros is important. We talked about zeros is another name for your x-intercepts. So we want to make sure that we know that or we're familiar with it. X-intercepts, remember, that's just where the graph crosses. Our x-axis. So what that's going to do is create those coordinates that look like some number, comma, 0, because our y value is 0. So x is some value, y is always 0. And we just look at this, we see it's going to cross here, again at 0, and again over here at 7. So it does say, write this in order from least x value, or the smallest x value, to the largest x value. This is going to happen a lot when we do our WebAssign questions, so that you'll have to write them in order. Our smallest x value is -4, so -4, 0. Then we have another one at 0, 0. And a last one over here at +7, 0. The third question is very similar to the first one. We're now looking at when is the function going to be greater than 2. So the function, this graph here, needs to be greater than 2. And if I find 2 on my y-axis, we can draw our imaginary line and look to see when that function will hit that imaginary line. So this function intersects it right there. It looks about maybe -2.5. And then again over here, and that's close-ish to 1.5. So if we use those two values to help write the answers, the first one is talking about greater than 2. This function is going to keep going up, so these values are going to be greater than 2. That's all the values that are left of -2.5. So that's going to be from -infinity to -2.5. We're going to put a parenthesis because it doesn't have the equal to part. It's just strictly greater than. Union, and then again it's going to be greater than for this section up here because this parabola is going to keep going in the positive direction there. So from 1.5 to infinity. All right. And number 2, the only thing that changed is that equal to symbol. So we now have a bracket at -2.5 and another bracket at 1.5. All right. And I know that we're going to be typing a lot of our answers since this is virtual, but make sure that you're writing things down that look like brackets. We have a bracket symbol, so use a bracket. It doesn't kind of look like a parenthesis. No, make sure it's very obvious so that it's helping you out in the future. And then the third one asks for less than 2. That's just going to be from -2.5 to 1.5. These both get parentheses because it's strictly less than. And our last one is less than or equal to. So now we get to include -2.5 and include 1.5. So these are just saying in the interval all x values between -2.5 and 1.5. And we are including those two values. All right. And that's all for this one. If you have any questions, just send me an email and we'll work on it together.